Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing prime numbers as well as how to quickly check a number for divisibility. As you can imagine, these two topics are related, and unfortunately, a lot of YouTubers don't make this connection. In other words, if you can check a number's divisibility, you can easily tell if a number's prime or not. Once I establish that connection, we're going to finish this video by taking a look at some practice problems that may or may not closely mirror what you'll see on the ASVAB. In the description of this video, I'm going to include timestamps that are associated with each section of this video. So there's going to be timestamps in regard to my discussion of prime numbers, my discussion regarding checking divisibility, and finally, my efforts to work out the practice problems in this video. In order to get the most out of this video, though, I strongly encourage you to work out these practice problems on your own. That is to say, once we get to the practice problems, you should pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. All right, so let's start our discussion of prime numbers by reviewing a definition of prime numbers. And as we can see, it says uh, prime numbers are natural numbers that are only divisible by 1 in themselves. The number 1 is not considered prime. And to the left here, I have a chart that includes the prime numbers from 1 to 100. More specifically, those prime numbers are circled in red. Now we have to understand this chart in order to be able to answer those questions that may appear on the ASVAB. So let's make an effort to do that. Why is 2 circled in red? That is, why is it prime? Well, 2 is prime because it's only divisible by 1 and itself. That is to say, 1 times 2 is 2. There are no other factors of 2. All right, let's talk about 3 now. Why is 3 prime? Again, it only has 2 factors, notably 1 and 3. 1 times 3 is 3. 4 is not prime because in addition to being divisible by 1 in itself, it's also divisible by 2 and 2. 1 times 4 is 4. 2 times 2 is 4. In light of that, it is not prime. 5 is prime because it's only divisible by 1 and itself. 1 times 5, of course, is 5. 6 is not prime because in addition to being divisible by 1 in itself, it's also divisible by 2 and 3. And because of that, it's not prime. Again, 2 times 3 is 6. All right, let's take a look at some numbers from the second row just to make sure we understand how to determine if a number is prime or not. So 11 is prime because it's only divisible by 1 and itself. 1 times 11, of course, is 11. 12 is not prime because in addition to being divisible by 1 in itself, it's also divisible by 3 and 4. That is to say, 3 times 4 is 12, so it's not prime. 13 is prime because it's only divisible by 1 and itself. 14 is not prime because in addition to being divisible by 1 in itself, it's also divisible by 2 and 7. 2 times 7 is 14. All right, so with this in mind, let's talk about some rules that we can use to quickly check the divisibility of a number, which will enable us, as you'll see in just a few minutes, to determine whether a number is prime or not. All right, so before we talk about how to quickly check the divisibility of a number, let me tie these two concepts together. As we just saw, a number is prime if it's only divisible by 1 in itself. In other words, if a number is divisible by 2, 3, 4, or 5, it is not going to be prime. And thankfully enough, we can quickly check to see if a number is divisible by 2, 3, 4, or 5 without having to do any long division whatsoever. And as you can see, we have rules that help us do that. So this first rule says, if the last digit of a number is even, the number is divisible by 2. So let's take a look at a few examples of this. Is 424 divisible by 2? Well, according to this, we look at the last digit, which is right here. It's 4. And since 4 is even, we'll say that yes, 424 is divisible by 2. And just to illustrate this, I'm going to work this one out via long division. 424 divided by 2. Uh, 2 goes into 4 2 times, 2 goes into 2 1 time, 2 goes into 4 2 times. 212 times 2 is 424 with no remainder. Okay, let's look at 543 now. Is 543 divisible by 2? Well, according to our rule over here, we look at the last digit, notably 3. Since 3 is not even, we know that 543 is not divisible by 2. And if you wanted to, you could work this out via long division. 543 divided by 2. And again, the goal is to get away from doing this long division. You want to use these rules to quickly say, yes, divisible by 2, no, not divisible by 2. Because again, if you know if something's divisible by 2, 3, 4, or 5, it is not prime. So 2 goes into 5 2 times without going over. 2 times 2 is 4. 5 minus 4 is 1. Drop down this 4. 2 goes into 14 7 times without going over. 2 times 7 is 14. 14 minus 14 is 0. Drop down our 3 now. 2 goes into 3 one time without going over. 2 times 1 is 2. 3 minus 2 is 1. In order to proceed doing this long division, we'd have to add a decimal here and a 0 placeholder. We would have to bring up our decimal here and drop our 0 down here. 2 goes into 10 5 times. 2 times 5 is 10 with no remainder. So as we can see, 543 divided by 2 is 271.5. That is to say, it's not divisible by 2 evenly. Okay? All right, let's look at 3 now. If the sum of the digits is divisible by 3, the number is also. So let's take a look at example 3 here. It says, is 168 divisible by 3? Let me scroll down a little bit here so we can see the rest of these examples. Is 168 divisible by 3? Well, according to this, if the sum of the digits in 168 are divisible by 3, then 168 itself is divisible by 3. So let's sum those digits. We have 1 plus 6 plus 8. This is the same as 1 plus 6, which is 7, plus 8, which is 15. Is 15 divisible by 3? Well, 15 divided by 3 is 5. So in light of the fact that the sum of the digits in 168 are divisible by 3, we can say yes, 168 is also divisible by 3. All right. Next, it says, is 1,000 divisible by 3? Well, again, according to the rule, if the sum of the digits in 1,000 are divisible by 3, then 1,000 itself is divisible by 3. So let's sum those up. We have 1 plus 0 plus 0 plus 0. 1 plus 0 plus 0 plus 0 is just 1. Is 1 divisible by 3? No. So in light of that, we can say that 1,000 is not evenly divisible by 3. Okay? All right, let's look at 4 now. 4 says, if the last two digits form a number divisible by 4, the number is also. All right, so let's apply that to a few practice problems here. Is 5216 divisible by 4? Well, according to our rule, if the last two digits of the number are also divisible by 4, then the number itself is divisible by 4. So the last two digits in 5,216 are 16. 16 is divisible by 4. 16 divided by 4 is 4. In light of the fact that those last two digits are divisible by 4, I know 5,216 is divisible by 4. All right, let's look at number 6 now. It says, is 125 divisible by 4? Again, we're looking at the last two digits of the number. Is 25 divisible by 4? It's not. So we can say with confidence and without having to do long division that 125 is not evenly divisible by 4. All right, and let's look at our final check of divisibility. We can see that it says if the last digit is 5 or 0, the number is divisible by 5. So in other words, we can quickly check to see if a number is divisible by 5. Is 125 divisible by 5? Well, according to that rule of divisibility, if the last digit of the number is 0 or 5, then it's going to be divisible by 5. In 125, the last digit is 5. 5 is divisible by 5, so this one is divisible by 5. And number 8 says, is 179 divisible by 5? Again, according to the rule, if the last digit is a 0 or a 5, then the number is divisible by 5. This is a 9. It's not 0 or 5, so no, 179 is not divisible by 5. All right. So again, those are the rules as to how you quickly check the divisibility of a number. And again, if a number is divisible by 2, it's not prime. If it's divisible by 3, it's not prime. If it's divisible by 4, it's not prime. If it's divisible by 5, it's not prime. So if you're given a question and you're asked to determine whether some numbers are prime or not, what you want to do is say, is it divisible by 2? No. Is it divisible by 3? No. Is it divisible by 4? No. Is it divisible by 5? If it's not divisible by any of these, chances are it's prime. If it is divisible by 2, 3, 4, or 5, it's not going to be prime. So let's take this one step further and let's look at some problems that will test your ability to determine whether a number is prime when you're given quite a few of them at once. All right, so we can see that this first practice question says, which of the following numbers is a prime number? We have 75, 102, 168, 195, 173. So again, prime numbers are only divisible by 1 in themselves. So if it's divisible by 2, 3, 4, or 5, chances are it's not prime. So let's start with 75. And let's run our checks. Again, we want to determine if it's divisible by 2, 3, 4, or 5. And we're going to use our rules to quickly check the divisibility of a number to do this. All right, to determine if a number is divisible by 2, we look at the last digit. Is that an even number? No. So 75 is not divisible by 2 evenly. Again, to determine if a number is divisible by 3, we sum the numbers. So 7 plus 5, that's 7, 8, 9, 10, 11, 12. Is 12 divisible by 3? Yes. So 75 is also divisible by 3. In fact, 25 times 3 is 75. So right here, we know 75 is divisible by 3, so it is not prime. All right, let's take a look at 102. And again, you want to check divisibility for 2, 3, 4, and 5. Is 102 divisible by 2? Well, let's start with the divisibility check for 2. According to that rule, if the last digit is even, it is divisible by 2. Well, 2 is even. So yes, 102 is divisible by 2, and therefore it's not prime. All right, let's look at 168 now. Again, we want to check divisibility for 2, 3, 4, and 5. All right, to check to see if a number is divisible by 2, we look at the last digit, and if it's even, it's divisible by 2. Is 8 even? It is. So we know that 168 is divisible by 2, and therefore it's not prime. All right, what about 195? Okay, we're going to check divisibility for 2, 3, 4, and 5. All right, to check to see if it's divisible by 2, we're looking at this last digit here. And according to that rule, if this last digit is even, it is divisible by 2. 5 is not even, so we know that 195 is not divisible by 2. To check whether a number is divisible by 3, we sum the digits in the number, and if that sum is divisible by 3, then the number itself is divisible by 3. So let's add these together. 1 plus 9 is 10, plus 5 is 15. Is 15 divisible by 3? Yes, it is. 15 divided by 3 is 5. Therefore, I know 195 is divisible by 3. What's more, if I wanted to jump ahead to 5, again, to check to see if a number is divisible by 5, we would say, we would look at the last digit, and if that last digit is 0 or 5, then it's also divisible by 5. This last digit is 5, so I also know that 195 is divisible by 5. Therefore, it's not prime. All right, let's look at 173 now. And again, we're going to run our checks. 2, 3, 4, and 5. All right, so to check to see if a number is divisible by 2, we look at the last digit. If that number is even, it's divisible by 2. Since it's 3, which is not even, we know that it is not divisible by 2. All right, let's run our check to see if it's divisible by 3. Again, to do that, you sum the digits in the number. So 1 plus 7 is 8, plus 3 is 11. Is 11 divisible by 3? It's not. All right, so let's move on to our check to see if this is divisible by 4. And again, to check to see if it's divisible by 4, you look at the last two terms, and if the last two terms are divisible by 4, then the number itself is divisible by 4. Is 73 divisible by 4? It's not. Okay. And finally, we're going to check to see if this number is divisible by 5. So let's look at this 3. According to our divisibility check for 5, if this last digit is 0 or 5, it is also divisible by 5. So in light of the fact this is 3, we can say with great confidence that 173 is not divisible by 5. And because of that, I'm going to say 173 is our prime number here. And again, I'm just going to check between 2 to 5. All right, so that's that one. Again, just run your divisibility checks. That will quickly rule out the ones that are prime or not prime, and then go from there. Now, as you can imagine, once you get very good at this, you'll be able to say, oh, that digit ends in 5, it's divisible by 5, even digit divisible by 2, even digit divisible by 2, 5 divisible by 5, and then you'd have to work on this one using your checks like this. All right, so let's look at another example here. All right, let's take a look at number 2. It says, which of the following numbers is a prime number? We have 33, 500, 111, 232, and 103. So if I was taking the ASVAB and I saw a question like this, I would be mindful of my divisibility checks, and right off the bat, I would say, this number ends in 0, so it's divisible by 5, therefore it's not prime. This number ends in an even digit, therefore it's not prime. So again, you want to get so good with divisibility checks that you can quickly eliminate numbers that are not prime. But that said, since we're practicing here, let's take this one step at a time. We have 33, and we want to check it for divisibility of 2, 3, 4, and 5. So let's go ahead and do that. Is 33 divisible by 2? Well, to check that, we look at the last digit in 33, notably 3. And if that last digit is even, it's divisible by 2. Since 3 is not even, we know it's not divisible by 2. All right, let's check to see if 33 is divisible by 3. Again, if the sum of the digits in the number are divisible by 3, then the number itself is also divisible by 3. 3 plus 3 is 6. 6 is in fact divisible by 3, so I know 33 is divisible by 3, and therefore it is not prime. Well, let's take a look at 500 now. Let's go ahead and do 2, 3, 4, and 5. And let's start with 5 because, again, you want to get good at identifying numbers that aren't prime by applying your divisibility checks. Again, let's check to see if this number is divisible by 5. According to that rule, if the last digit in the number is 0 or 5, then it is divisible by 5. As we can see, the last digit in 500 is 0. Therefore, I know 500 is in fact divisible by 5, which makes it not prime. All right, let's take a look at 111. And we want to check for divisibility by 2, 3, 4, and 5. All right, this one's a little bit of an oddball number, so I'm going to do my divisibility checks in order for this one. Again, to determine if it's divisible by 2, we look at the last digit here, and if that number's even, or that digit's even, it's divisible by 2. If it's odd, it's not divisible by 2. As we can see, it's 1, so it is not divisible by 2. All right, to determine if a number is divisible by 3, we sum the digits in that number. So 1 plus 1 plus 1. 1 plus 1 plus 1 is 3. 3 is divisible by 3. Therefore, I know 111 is divisible by 3, and therefore it is not prime. All right, let's go ahead and do 232 now. We're going to run our divisibility checks for 2, 3, 4, and 5 now. And again, to check to see if a number is divisible by 2, we look at the last digit there. If that last digit's even, it's divisible by 2. As we can see, it is 2, which is an even number. So we know 232 is divisible by 2. Therefore, it is not prime. All right, let's look at 103 now. And again, we're going to run divisibility checks for 2, 3, 4, and 5. In some cases, you might have to go beyond 5, but for the most part, do 2, 3, 4, and 5, and that should give you your answer. All right, to check to see if it's divisible by 2, we look at this last digit here. If it's even, it's divisible by 2. If it's not even, it's not divisible by 2. Our last digit here is 3, which is odd, so we know this is not divisible by 2. Let's check to see if this is divisible by 3. Again, to see if it's divisible by 3, we're going to sum its digits. Notably, we're going to do 1 plus 0 plus 3. 1 plus 0 is 1, plus 3 is 4. Is 4 divisible by 3? It's not. Therefore, I know 103 is not divisible by 3. All right, to see if a number is divisible by 4, we look at the last 2 digits of the number. In this case, that's 03. And if the last 2 digits are divisible by 4, then the number itself is divisible by 4. Is 03 divisible by 4? It's not. And finally, we're checking for divisibility of 5. So we're looking at the last digit in this number. And if that last digit is a 0 or a 5, then we know it's divisible by 5. In this case, it is a 3, which is neither 0 nor 5. So we know it's not divisible by 5. Therefore, I'm going to say 103 is the prime number here. Okay, so that's that one. All right, let's look at this final problem and then we'll be done for the day. Again, it says, which of the following numbers is a prime number? We have 39, 363, 117, 911, and 177. And all of these numbers are a little bit unusual, so I'm going to run my divisibility checks in order this time. We have 39, and we want to check to see if that's divisible by 2, 3, 4, or 5. Again, starting with our divisibility check for 2, we look at the last digit here, and if it's even, it's divisible by 2. Is 9 even? No, it's odd, so we know this isn't divisible by 2. To determine if a number is divisible by 3, we sum the digits in that number. So in this case, we would do 3 plus 9, that's 9, 10, 11, 12. If the sum of the digits is divisible by 3, then the number itself is divisible by 3. Well, 3 plus 9 is 12. 12 is divisible by 3. Therefore, we know 39 is divisible by 3. So we can stop checking this. We know this 39 is not prime. Let's move on to 363 now. Again, we're going to check divisibility for 2, 3, 4, and 5. All right, to check for divisibility for 2, we look at this last digit. If it's even, it's divisible by 2. If it's not even, it's not divisible by 2. It's 3, which is odd, so we know it's not divisible by 2. To determine if a number is divisible by 3, we sum the digits in that number. So we're going to do 3 plus 6 plus 3. 3 plus 6 is 9, plus 3, 9, 10, 11, 12. So is 12 divisible by 3? It is. Therefore, I know 363 is also divisible by 3, and therefore 363 is not prime. Let's look at 117 now. Okay, we're going to run divisibility checks for 2, 3, 4, and 5. Again, to determine if it's divisible by 2, we're looking at this last digit here. Is 7 even? No, it's odd, so we know it's not divisible by 2. Again, to determine if a number is divisible by 3, we sum the digits in that number, and if the sum of that digits is divisible by 3, then the number itself is divisible by 3. So 1 plus 7 is 8, plus 1 is 9. Is 9 divisible by 3? It is. 9 divided by 3 is 3. So we know that 117 is also divisible by 3, and therefore it's not prime. What about 911? We're going to run our checks for 2, 3, 4, and 5. Let's start by checking to see if it's divisible by 2. We look at this last digit. If it's odd, it's not divisible by 2, and we can see it's 1. So this is not divisible by 2. Let's go ahead and check to see if it's divisible by 3. Again, to check that, we sum the digits in our number. So 9 plus 1 is 10, plus 1 is 11. Is 11 divisible by 3? It's not. Therefore, 911 is not divisible by 3. To check to see if a number is divisible by 4, we look at the last 2 digits, and if the last 2 digits of a number are divisible by 4, then the number itself is divisible by 4. Is 11 divisible by 4? It's not. Therefore, this number 911 is not divisible by 4. And finally, to check to see if a number is divisible by 5, we're going to go ahead and look at the last digit. If that last digit's a 0 or a 5, then it is divisible by 5. Since it's a 1, it's not divisible by 5. So right now, I'm going to say 911 is the prime number, but I want to check 177 first. All right, and we're going to run divisibility checks for 2, 3, 4, and 5. All right, to check to see if it's divisible by 2, we look at the last digit. If it's odd, it's not divisible by 2, so 177 is not divisible by 2. To check to see if it's divisible by 3, we sum the digits in 177, and if the sum of those digits is divisible by 3, then the number itself is divisible by 3. 7 plus 7 is 14, plus 1 is 15. 15 is divisible by 3. 15 divided by 3 is 5. Therefore, 177 is divisible by 3, and it's not prime. So by process of elimination, I know 911 here is the only prime number. All right, so that is it for this video. I hope you found it helpful. Again, my goal was to tie these two concepts together, notably the idea of checking divisibility in order to quickly determine whether a number is prime or not. And as you saw, that's very useful for questions that may show up on the ASVAB. As always, you're more than welcome to leave feedback in the comment section below. If you like the content I'm creating, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.